Welcome back, my dear students. I believe you're doing well with integration. So, yeah, let's continue with integration. The next part of integration, that is methods of integration. Methods of integration, that actually, which means that we will be doing, we are moving towards the exercise 7.2. Exercise 7.2. Now, in this methods of integration, I believe you're practicing well with the previous exercise. With methods of integration, we have the first method, that is integration. Integration by substitution, S-U-B-S-T-I-T-U-T-I. These spellings become quite confusing. Integration by substitution. Okay, the second method that we have is integration. I'll just write integration using partial fraction. Integration using partial fraction. Then, of course, the next method is integration by parts. Now we have these three methods which we will be learning one after the other with respect to the exercises. Integration by substitution, integration using partial fraction, integration by parts. Now what are these? These are just methods, as it mentions, okay, methods to make our integration a lot easier, but it's just that I can't give you an algorithm on any of these methods actually, like step 1 do this, step 2 do this. No, it's not something like that. These are just some methods which we will be learning with practice. Okay, it's just some methods which we will be learning with practice, because if you remember integration, I had shared with you that it's not exactly like differentiation, because we don't have this product rule, we don't have this quotient rule, we do not do the differentiation, we did it for implicit functions, we can't do that for integration, because differentiation, okay, x with respect to y, but integration is x, a function of x with respect to only x. You cannot integrate a function of x with respect to another variable, so even the variable of integration also has to be same. So we have this certain rules in integration which is unique for itself, so we have to maintain that. So for that, of course, we need more methods. So these are some of the methods which are given to us, which we will learn for what? Just to make our integration a lot easier, because some functions might be, you have seen already in the first exercise that okay, that was just practice, simple integration, but functions won't be as simple as those exercises in exercise 7.1. It's definitely going to be more complicated. Now, to solve bigger complicated functions, we need these methods. Okay, no problem, we will learn one by one. So I'm going to rub this too, let's not confuse. This one we will learn. Of course, last one, if you see integration by parts, that's somewhat similar to another way of like the product rule. Not exactly so, but something like that, but forget about that, we are going to learn about that later on. Now, integration by substitution. So as the name suggests, what we will do here is we will substitute and integrate. That's why it's called integration by substitution. Certain functions which might look too big, complicated, not possible to integrate, we will use the substitution method. We'll use the substitution method and then integrate. But yes, for that, of course, differentiation would be very important, as I have always said before. I will continue to say so. If your differentiation is still weak, please get this differentiation sorted out, because that is really going to be needed. Because only when you have a proper concept of differentiation, integration is going to be a lot easier for you. Okay. Now, what do we do here? As I said, I cannot give you an algorithm. Because it's all about identifying, imagination, and then with practice only we get better. But we are here for practice, so let's see what we do with this substitution. But for that, as I said, differentiation. If we can have a function and its derivative in a given function, in a given question, then that's where we use substitution. Not always, but yeah, that's also one way of identifying. We have a function and its derivative of that function is also there So that's where we use substitution. That's why I say derivative, differentiation, very, very important. Like for example, if we just take one example like this. One example. I can teach you only with true examples here, okay? Because as I said, we don't have any algorithms or steps to follow to be specific here. It's just about identifying. Yes, there are some shortcuts, some formulas which will make our job easier. Definitely, I'm going to give you that. I will. But let's learn actually like how it works, and after that, it's going to be a lot easier for you to understand also. Now, if you look at this particular function, see we have this formula for integration of x power n with respect to x, that is x power n plus 1 upon n plus 1 plus c. We have that, but we have it only for x. We don't have that for a polynomial function of x. We have here 3x plus 5. So differentiation too, we could just do chain rule. That was easy for us. Integration generally, yes, there are some shortcuts, as I said, I'll give you that, but we will use substitution here. Now what I'll do is, maybe if I can just substitute this whole function as t. So that's the first step. Yeah, I can give you a small algorithm. Let's first identify the function, then we can substitute the function as t. So now I will be using the variable t. So in that case, this variable of integration also has to change, because as I said, integration, you cannot integrate t with respect to x. Unlike differentiation, we can't do that. So even x also, dx with respect to x also has to change. Now, for that, that's the second step which I can tell you, that is, once you identify which function to substitute, after substituting, you will differentiate both sides. That is, differentiating both the functions, both sides with respect to x. Should I write? Okay, second step is like differentiate, D-I-F-F-E-R-E-N-T-I-A-T-E, differentiate. Differentiate both the sides. Now, why do we differentiate? We will very soon get to know. So, then. So differentiating both sides, what will we have here? So differentiation, so I'm going to get over this quickly. So we will have only 3. That is with t with respect to x. Now my job, I am trying to just replace this. So cross multiplying dx, I'll write dt by 3. That's fine. So after that, we can go back to our question. That is now. I equal to this. I think this is done. You can always pause the video and note it down. And once that is done, I will have, now this I have replaced it with t power 7. dx I can write now dt by 3. So this 3 is a constant, immediately take it out. Integration of t power 7 with respect to t. Now you can see that this is almost, just the variables are different. It's exactly the same, x power n with respect to x, so it's t power 7 with respect to t. So then I can use formula, that is 7 plus 1, okay, 1 by 3 into 7 plus 1, 8 divided by 3 plus c. So that's going to be t power 8 by 24 plus c. So now I can replace the value of t, that is 3x plus 5 whole power 7 by 24 plus c. So that's what we will be doing with this integration by, of course, problems are going to get more and more complicated, but yeah, this is one way of substituting. And sometimes, of course, what happens is in the function, even its derivative is also given. So if you can identify that, then immediately we can, we can just get to know. That comes to you when we practice enough, okay? So it will immediately come to you that, okay, I substitute this function because its derivative is already in this function. So, okay, this is what you'll just get to know. All you have to do is, in the beginning, it might be a bit, tough for you, confusing for you. You just have to don't give up, okay? Practice, alright? Okay, so that's what it is. If the first, some of the common problems. I'll give you some more problems. Now, once this is done, I'm going to give you one formula. But again, as I say, especially this exercise, please complete this exercise by the usual substitution method. Or should I give you in the last? Okay, I'll give you in the last. Should I give you now? Okay, I'll give it to you now, the formula, but please, one advice is please do all the problems without using the shortcut problems, formulas. Finish the exercise first. Once you think that you're good at it, after that, okay, maybe you can use the shortcuts, because we need to know the process also. We need to know the procedure also. Okay, so I'll give you the formula. That is, this is the first one. Okay, number 1. That's the first theorem. I'm going to rub this off. So now it says, okay, you can write down. I hope you've brought your pen and paper and all. Like, it's integration of ax plus b whole power n with respect to x. So far we had only this formula. I'm going to give you now this one. That is, integration of a and b are arbitrary constants. So ax plus b whole power n with respect to x will be ax plus b as usual, n plus 1 divided by n plus 1. Almost, the same, slightly the same concept like the chain rule. So we'll just ignore this as x, continue with the formula. But what we will do is, after it is done, denominator, this value you will divide by the coefficient of x. What is the numerical coefficient? So what is the coefficient of x here? Not numerical, sorry. The coefficient. So what is the coefficient of x? The coefficient of x is a. So that's what you will be doing. So this is your new formula. Now, let's try to apply that in the same formula and see whether we get the answer or not. I think this is done. We have the answer there. We will compare. So now this is not needed. Okay, let's try using the formula directly. That is ax plus, it can be minus also, but again, I say another hint, don't worry about the constant term. Your job is just to focus on the variable term only, that is its coefficient only. Okay, minus, plus, 100, 1000, forget it. So now ax plus b whole power n. So that's like, as I say, just ignore, just carry on. 7 plus 1 8 divided by 7 plus 1 8 plus c, and divide by the coefficient of x, 3. Don't we have it? 3 8s are 24. It's the same. 3 8s are 24. Okay, so that's that's how you can complete 3x plus 5 whole power 8 by 24 plus c. So we have the same value. Sorry, this was 8. Okay, please, please, I'm very sorry. Please correct it. Alright, please correct it. Okay, so that was 8. Sorry, not 7. Of course, careless mistakes. I'm also human. I will also make those mistakes. So 3x plus 5 whole power 8 divided by 24. So we have the same solution. Alright, so that is the first first formula for you. So maybe from the next exercises, when we do some bigger questions on special integrals, integration by parts and all, you can just start using these formulas. Okay, now let's try another formula, that is not formula, another question. These are all examples. Integration of cos, let's say 2x with respect to x. Integration of cos 2x with respect to x. Now here also we know that we have the formula for integration of cos x with respect to x, which is sin x plus c. But we don't have for sin cos 2x. So what I'll do is, I'll substitute. Let 2x be t. Got it? So then what is the next step? Differentiate. So okay, both sides with respect to x. So that will be 2 dx. Sorry, I'll just write step by step. This is just the beginning stage. So that's going to be, I have to replace dx. Dx is equal to what? dt upon 2. Now I'll get back to my function, and that will be integration of cos t. Now dx is replaced by dt by 2. So now that is 1 by 2 integration of cos t dt. So that's the same as the formula, just the variable of integration is different. So now I can just use integration of cos x is sin x. So that's sin t plus c. So that can be 1 by 2 sine t value I can replace 2x plus c. So this is my solution. Alright, so that's how we can integrate. Got it? Now for that, okay, na? Now for this also I'll give you another formula, another shortcut formula. It's almost the same like the first formula that I gave you. When you have integration of cos mx with respect to x, what you can do is again that same concept which I gave you for the first part, that is just ignore this mx, just integrate, that is sine of mx plus c, but divide the value by the coefficient of x divided by m. You get the solution. Let's check again. So this is the second part. So I equal to integration of cos 2x will be sine 2x, but I'll divide by the coefficient of x, that is 2 plus c. That's fine. 1 by 2 sine 2x plus c. Alright, so but as I said, as I requested, see to it that you start using this only after you have fully done the exercise. Maybe from the next exercises onwards you can start using this slowly. Okay, not now, first learn the process. After that, don't directly jump into the shortcuts immediately. No, that's not good. Okay, all right, then another one, maybe chalo, let's see. Okay, let's do this. That's the third one. I equal to, okay, that's fine, e power tan inverse of x upon 1 plus x squared with respect to x. Okay, now in functions like this, what do we do? Which ones do we substitute? And that's where the second concept that I gave you, that is like, if we can identify one function, and then in that function, if that derivative of that function also if you can identify, then it's very easy for us to find out or to decide on which function to substitute. Alright, now that, whether you have noticed or not, I have noticed, that is, see, tan inverse x is a function, and what is the differentiation of tan inverse x? Differentiation of tan inverse x is 1 by 1 plus x squared. So like that, no, that's why I was telling you there is no algorithm for this. It's all about identifying. That can be done only with practice, and differentiation is a must. So I'll substitute, let tan inverse x be equal to t, then differentiating both sides with respect to x. I don't want to be writing this step every now and then, but anyway, during the exercises and all, I'll be skipping this step. So that's 1 by 1 plus x squared. I'll just directly do this, dx is equal to dt. Now either you can just replace the value of dx, or you can just keep it as it is, because again, as I see, I have already identified this function is already in the function, so the whole term can be just replaced. This whole term can be just replaced by dt instead of just dx, again cross multiplying, again cancelling and all. If you can just identify and just keep it, you can just replace it immediately. Okay, so then my function I becomes e power t, because this is t. Now this whole term dx by, this is always on the numerator side, isn't it? That we know. Dx by 1 plus x squared, is whole term can be just written as dt. So that's integration of e power t is what? E power t plus c. So e power, what was t? Tan inverse of x plus c. Alright, so that's the way we do, this is what we will be doing in this exercise, in exercise 7.2. Now before we wind up, this is just the intro class, just to teach you on what we are going to do in the next exercise and all. I want to give you some formulas. See, integration, if you have noticed, we didn't get formulas on integration of tan x. You can check your books. We didn't get formulas on integration of tan x, we didn't get formulas on integration of cot x, and some trigonometric functions, because for differentiation derivatives of all the trigonometric functions were there, but not for integration. That was because it is derived using substitution only. So let's see. First one. These are formulas, you can note them down also. First one, I'll give you the proof. The other ones, you can also try the proof, to get the proof. Integration of tan x with respect to x, that is I. So what is the formula for integration of tan x with respect to x? Let's derive using substitution. That is integration of tan x can be written as sin x by cos x with respect to x. Now here we can see that a function and its derivative is already there. So let us substitute which function? Yeah, better we substitute cos x, then only we'll have the numerator part. So let cos x be equal to t. Then I'll do directly. Differentiating both sides, I'll have minus sin x dt by dx. So in that case, sin x dx is equal to minus dt. That's why I substitute cos x, because sin x dx, I knew that if I use cos x, I'll get sin x. So it's on the numerator. Sin x dx will be what? Can be replaced as dt. Of course, we have a negative sign there. Now, with that done, my integral becomes sin x dx is minus dt. Cos x is t. So that becomes minus 1 by d. Derivative of t. So this is 1 by t is what? Log of t. Don't confuse. If you remember last exercise I was telling you. So that's minus log of, what was t? Cos x plus c. So this is the formula for integration of tan x, and that is how we derive integration of tan x. So you can just note down this formula. Okay, you can note down this formula and you can use that in the future. That is, integration of tan x is minus log of cos x plus c. There is another representation of this particular formula. So this is the first one, integration of tan x. If it doesn't serve your purpose with that particular question, there is another way of representing this formula by simple simplification. That is, this one, we can also use like log of cos x, because see, we know this formula for log, no? That is minus log m is also log of 1 by m. That's what we know, isn't it? Minus log m, because of the concept that comes with m power minus 1 is like log, because I wonder how many of you are clear with this logarithm. If needed, then definitely I'll do a special video on log also, because we know that we have this concept on log, that is log x power n is n into log of x. So using that concept, minus log m can be also, minus means minus 1, so that will be what? Log of m power minus 1. So that is m power minus 1 is also 1 by m. So this is how it comes. So this is something like a formula which you can note down. Okay, minus log directly, because every time we cannot do all these steps. So minus log of any function will be log of 1 upon that particular function. So now that means I'll just apply this log of 1 by cos x. Okay, I'll just use the modulus value, magnitude value. It's always going to be positive, that's why we use this. Okay, I'll rub it off. So then what is 1 by cos x? 1 by cos x is log of sec x. I've explained why we use this mod sign before. So this is your second formula. So that means integration of tan x has two variations. That is, first one is minus log of cos x plus c. If it doesn't serve your purpose for that particular question, you can also use log of sec x plus c. So that's what we have with this trigonometric formulas. Okay, now the rest, this is the first one. The rest, I'll not do the proof, that I'll leave it to you to work out. If you are not able to get any proof, then you can of course let me know. I'll give you the proofs of the other functions. That is the second one. that is integration of cot x. Integration of cot x with respect to x. Integration of cot x with respect to x is log of sine x plus c. Okay. Third one, integration of sec x. Integration, this were not given, okay, in the formulas. Integration of sec x will be log of sec plus tan x plus c. Of course, indefinite integral. So this ratio, this constant of integration will come. So integration of log x, sec x is equal to log of sec x plus tan x plus c, which is also another way of representing is log of, another way of representing will be log of tan pi by 4 plus x by 2 plus c. So in either one, any one that you can use, okay. I repeat once again, integration of sec x with respect to x is log of sec x plus tan x plus c, or log of tan pi by 4 plus x by 2 plus c. Now the fourth one, that is integration of cosec x with respect to x. Integration of cosec x with respect to x will be, I guess you can guess, log of cosec x minus cot x plus c. Log of cosec x minus cot x plus c. Or another way of representing it would be integration of log tan x by 2 plus c. The angle x by 2, not tan x whole divided by 2, no, tan of x by 2. Okay, tan of, not, yeah, tan of x by 2. Alright, so you can use either one, either this one, or you can even use the second one. That depends on which one is needed. Either this or this, depends on which one is needed for your solution. Either cos x minus cot x plus c, or log of tan x by 2 plus c. That depends on you. Alright, so these are some of the formulas, and as I've said, these are just derived using substitution processes only. So first one I've shown, it's not, maybe not be exactly the same way of proving, but yes, by substitution method only. So you can give it a try and practice. Alright, so next video we will start with the exercise, so you can just prepare yourself and get ready with differentiation also. Please practice differentiation well enough. That's really going to be very important for you. Okay, alright then, so please do study well. Take care. Any problems, please do let me know. Bye bye.